Hey all, hope you're doing great. In the previous video, I taught you how to implement the EIGRP dynamic routing protocol. So if you want to learn how to do that, or if you want to check out how to do the RIP dynamic routing protocol or the or static routing protocols, or if you simply want to learn how to make this topology and assign these IPs, I will include those video links in the description below. Today, we're going to learn how to implement the OSPF, or the Open Shortest Path First Dynamic Routing Protocol, which is basically a link state routing protocol, something that we don't need to go into in this video. I will inshallah upload the video of link state routing protocol in a few days as well. So what you need to know about the OSPF protocol is that it uses another additional thing other than the ID that we used in EIGRP. It also uses an area, which basically means that area 1 routers are all those routers that are logically connected to the OSPF that we're going to implement today. And it also has another thing that's called the wildcard mask, which you calculate using the subnet mask of your class. And I'm going to show you how to do that. So in our topology, we're using A class. And let's go ahead and calculate the wildcard mask for A class. I've also written the wildcard masks of A, B, and C class. The way you do that is that you write 255.255.255.255. So all four octets have to be, have all their bits on, and you subtract the subnet mask of your class from that. So the subnet mask of class A is 255.0.0.0. So we're going to go ahead and subtract that. So obviously 255 minus 0 is going to give you 255, and 255 minus 255 is going to give you 0. So it's going to get 0.255.255.255. In the same way, if you wanted to calculate the wildcard mask for B class, you would have written the subnet mask of B class over here, which is 255.255.0.0. And this is the wildcard mask that you would have gotten. And for C, the subnet mask that you would have written over here would have been the 3 octets with all bits on, so 255.255.255.0, and then after subtraction, this is the wildcard mask you would have gotten. So now that we have all the parameters, let me show you how we put these into the commands, and then how we can implement the OSPF routing protocol. So let's go ahead and start. You click on a router, go to the CLI, press enter, enable, config T, then you're going to write router OSPF and then your process ID, which for the example today, we're using the process ID 10. So you write OSPF 10, then you write network, and then just like RIP and EIGRP, you're going to write the networks that are directly connected to that router. So indirect connection is first of all 4.1.1.1, and then you give a space and you write the wildcard mask. So as we're using A class, the wildcard mask we're going to use is 0.255.255.255. Then you give another space, and then you write the area, which we're using area 1 for our example. And now that you've done that for 4.1.1.1, you're also going to want to do that for 5.1.1.1, and then the other indirect connection is 1.1.1.1. So let's also do it for that. Then all you need to do is just exit. And let's do that for the next router. So CLI, enter, enable, config T, router OSPF, the ID, which is 10, network, and let's see the direct connected networks with this router. So first we have 4.1.1.2, then the wildcard mask, and then the area. The next direct connected network is 6.1.1.1, and lastly we have 3.1.1.1. And then let's exit. Let's do it for the last router as well. Enable, config T, OSPF 10 and network. The direct connected network is 6.1.1.2, wildcard mask, and find the area. Okay, and you can see that the connections have started going up right now. Then the next one is 5.1.1.2, and then we have 2.1.1.1. There we go. Let's go ahead and write exit. And now if we were to write show IP route, wait, let's, okay, show IP route, we'll see that 6, 2, and 5, so 2, 6, and 5 are in direct connection, which is represented by C, and then the rest of the networks are connected through OSPF, which is represented by no. Let's also show IP route for another router so that you can get a clear idea. As you can see, the direct connected interfaces 3, 4, and 6. 3, 4, and 6 are in direct connection represented by C, and then the rest of the interfaces, the rest of the networks are connected through OSPF. Let's go ahead and see if we can send messages successfully from an end device in one network to an end device in another network. Double click and you can see that it's successful. Let's try that a few more times. And then let's also see if that works when we send messages from a router in one network to an end device in another network. So as you can see, we have successfully achieved our OSPF dynamic routing protocol. That's it for this video. If you have any questions or if you have any requests for any more videos, let me know in the comments below. See you next time and hope you learned something.